Hello everyone, I'm Sibei from the University of Hong Kong. I'm going to present our work in the referring expression reasoning. Grounding reference expressions aims to locate in an image an object referred to by a natural language expression. The challenge is that the referring expressions is generated in an unstrained sense, which normally not only describes the appearance of the reference but also its relationship to other objects. We address the challenges from three perspectives. First, we perform visual reasoning on the top of the relationships among the objects in the image. As shown in green box, the relationship among the table, girls, and their clothes should be considered. Second, human visual reasoning of grounding is guided by the linguistic structure of the reference expression. As shown in pink box, the linguistic structure of the expression is a tree structure which provides a tree structured reasoning layout of identifying the blue smoke, finding the table, and then locating the girl who is in blue smoke and is across the table. Third, explicit alignment between the linguistic components and the visual context provides a reliable and interpretable reasoning process. As shown in blue box, for every non-phrases, its corresponding visual regions should be matched. In summary, we contribute a normal graphic structured reasoning method and also developed the reference reasoning, which is a large-scale real-world dataset for structured referring expressions reasoning. For the method, we propose a thin graphed guided modular network which performs graph structured reasoning over thin graphs with neural modules. In particular, we model the image as a structured semantic graph and parse expressions into a language thin graph. It provides a reasoning layout to identify the reference. Next, we perform structured reasoning using neural modules from bottom to up over the language thin graph. For each leaf node in the graph, we independently find its relevant nodes among the nodes of image's semantic graph using attended node module. For the example, for the leaf nodes of the blue smoke and the table, we directly find its corresponding visual regions. For intermediate nodes which have incident edges, its relevant nodes in the image semantic graph should depend on the corresponding visual context and its connecting nodes and the edges between them. For example, for the node of the girl, its corresponding visual objects not only depends on the node itself but also relies on its relationship with the identified blue smoke and table. We independently obtain an attention map for subject node in an edge and then merge these attention maps from all the edges. First, we find the girl in the green box for the edge, the girl in blue smoke, and find the girl in blue box for the edge, the girl across the table, respectively. And then merge those results to identify the referent girl in the red box. For the dataset, we also propose reference reasoning will automatically generate expressions over the thin graphs of the images using diverse expressions templates and functional programs. The two examples based on two different reasoning layouts, the relationships among the objects can help to distinguish the reference from other objects which belong to the same categories as the reference. The another two examples are generated using different expression templates from the same layout. Reference reasoning dataset includes about 800,000 expressions in about 84,000 images, and there are hundreds of objects, relation, and attributes classes. Experimental results demonstrate that thin graph-guided modular network improves the grounding accuracy and interpretable in reasoning. In Figure A, it compares these expressions into a tree structure and finds the referred woman who is walking a dog, and meanwhile it with pink and black hair. In B, shows a more complex expression which describes four objects and their relations. The module further successful changes from the initial attention map to the final attention map at the node a chair by performing relational reasoning along the edges of a chair to the left of a lamp and the lamp on a floor, and then identifies the target blanket on that chair. The dataset and code are available. For more information and details, please refer to our paper. Thank you for listening.